Okay, in this video, I'm going to cover following contents. Let's see. First, I will explain you the need of face detection, and then I will explain the Viola-Jones algorithm that will be used to detect the faces, and I will explain one example MATLAB code for face detection in images. After that, I will explain another MATLAB code for face detection in videos in real time, and in last I will explain one MATLAB code for face database creation. Before watching this video, I recommend you to watch my this previous video. This video actually explains about the webcam and IP-cam interface with the MATLAB. Here you will learn that how you can access the webcam of your laptop or PC, or how you can connect some external USB webcam to capture images and videos. So it is important to watch this video before this current video. Now let us see what is the need of face detection. Before it, first let us understand what is the difference between the face detection and the face recognition. The face detection means to distinguish between the faces and the non-faces objects in an image or video. Okay, and face recognition means the whose face is this. So that is a basic difference. Now let's see what's the need. Actually, there are several projects which require the human faces as a primary input for their implementation, such as the face recognition and face recognition based the security systems, attendance systems, and you can recognize the facial expressions also, and on the basis of the facial expression you can do the mood analysis. And there are many such applications or projects that you can implement it where the faces, human faces, are required as a primary input. So now let us see what is a Viola-Jones algorithm. Actually here I am not going into the theoretical details. My main objective here is to implement this in MATLAB to detect the human faces rather than the theoretical background. But I am just giving a brief about the Viola-Jones here. It's an algorithm which is developed by Paul Viola and the Michael Jones in year 2001. So it's a object recognition framework that allows the detection of the human faces. Although it's a very old framework, but it's quite powerful, robust and faster. Therefore, it is found exceptionally notable in real-time face detection. So since it is very fast, that's why it is mainly used for the real-time face detection applications. There are 4 stages of this algorithm. The first one is it uses the hair-like features for detecting the shaded areas, various areas in images, such as for example, the eyes are more darker than the cheeks area, while the nose bridge is much brighter than the eyes area. So some hair-like discrete features are used in this algorithm. Then an integral image is created from those features, and the adaptive boosting is used for training, and then the cascaded classifiers are used. So if you are really interested in the theoretical details, I recommend you to download this research paper from this link, which explains the original work of Viola-Jones for face detection. This link you can find in the description. So now let us see that how Viola-Jones algorithm is implemented in MATLAB. Actually, in MATLAB there is a vision cascade object detector which utilizes the Viola-Jones algorithm for face detection, and this you can find in the computer vision system toolbox. So to implement these programs, you need the computer vision toolbox installed on your computer. So this object detector actually uses this Viola-Jones algorithm. It can detect the human faces, nose, eyes, mouth and the upper body of the human. And this object detector system objects comes with several pre-trained classifiers for detecting the frontal faces, profile faces, nose, eyes and the upper body. However, these classifiers are not always sufficient for a particular application. So, the computer vision system toolbox provides the facility to train a custom classifier on our own image database. That means if you have your own image database, you can train this classifier of MATLAB. And this Cascade object classifier or detector, it can also be trained for the non-facial images also, such as the traffic stop signboards you can identify in the images. Even you can identify the cars which are viewed from a particular angle. But the primary requirement is that the aspect ratio should remain fixed for such images for the better results. Here in these two figures you can see that in this figure the classifier is trained for identifying the stop signage, traffic signs, and here it can identify the cars from the back side. It is trained to identify the images car images from the back side. You can train from the front side also. And now to use it for faces or upper body, what we have to do, what are the steps? The steps are simple. First we will create a vision.cascade object detector object in MATLAB, and we can change its properties, and then we will call these objects with some arguments as we call a function, similar to a function. So, let us see how this is created and utilized to detect the human faces in images in the upcoming MATLAB code. Okay, now let us see the MATLAB code for face detection in images. This is the code. Here when you execute this first line, that means the UI get file, a system dialog box appears where you can choose your file, and then using this imread your file, that means your image will go to this variable img, and here we are defining the vision.cascade object detector face detector object, and in this line we are changing its threshold value. That means it is one of the attributes that is used by this Cascade object detector. Although its value 4 is the default, but we can adjust it for better detection. With the proper examples, I will show you that how you can adjust its value to get the better detection. And now using this face detector object similar to a function where the image img is passed in it, and it returns the bounding boxes. Bounding boxes means if face is detected, then a surrounded bounding box is returned by this face detector object. And here we have put some conditions. That means if face is detected, that means it is returning the bounding boxes. Then we insert the annotation with the name face in the rectangle. That means if face is detected, then we insert its label. So here we are writing the annotation face, so that you can clearly see in example when I will run this program. And then we display this image using IamShow with this title. Else means if suppose there is no face is detected, then we insert the text on image at the location 0 0, that means the top left corner, with this tagline, that is the no face detected. You can change its font size, you can change the opacity of the box of this text, and then we display this image. So let me run this program into MATLAB. So let me open the editor. So this is my editor. This program is already written here. Let me first run this program by pressing this run button. So here I can choose my image. So let me choose this image. Here I can see the lots of people in a group. So when I run this, yeah, I get this type of output. So that means all faces are clearly detected. So let me try one more example. Let me choose this one. And again, yes, all the faces are detected. And let me try one more example, this one. And oh, there's a problem here. This phase is not detected, so I can adjust the threshold value as I said for better detection rate. So I can reduce its value to the 5, and let's see what happens to the result. So let me run it again and choose this file, and okay, now it's working fine. So all the faces are identified in this image. So let me try one more example with this value of threshold. Here I have the image of one of the Hindu god, Ram. Let me try it. Yes, it is detected, but you can see there is another small face is also detected. So by the way, it's a face of the sun. But if you do not want this small face, then you can increase the threshold value. Let's say I can increase to the 10, and then you can remove this false detection. So yes, it is removed by increasing the threshold value. Although it is a face, it recognizes well those eyes and nose. But if you do not want it, you can adjust the value of the threshold. Okay, now let's try one non-facial image as input to this program. So let me run this program and select this flower image. So let's see what type of output I will get from this input image, rose, flower. So this is the output. Yes, of course, since there is no face here, so it says that no face detected in this image. Okay, so this is how you can detect the faces in images. So let me jump to the presentation. Okay, in this MATLAB code, I will show you that how you can detect your face in a video in the real time. So here I am using my laptop inbuilt webcam to capture my face, and I will show you that how my face is being detected by this program. So this is the program. The first line actually declare a webcam object. The more detail about this you can find in the previous video, which I have explained in just beginning of this lecture. The link is as I said given in the description. The first I am taking one snapshot, and then from that snapshot I am finding the size of that video, and then with that size I am just creating a video player object. So that means I am creating a video player object with that frame size, so it can properly display my frame, captured frame or captured video. And the position is the starting position is 100, that is the first corner. You can change as per your requirement, it doesn't matter. And then defining a condition to enter in the while loop. So run loop equal to true. So with this we enter in this while loop, and while loop starts. So it will continuously run until this condition becomes false. So later I will show you that how it becomes false. So first snapshot is taken, and then frame is captured in IMG. So it is passing into the face detect function. So what is this face detect function? I will explain in the next slide. Its output is actually the bounding box points and the cropped image. Although for this particular program I am not using this cropped image. This will I will use in the next program for face database creation. I am here just using this only output, that is bounding box points. So with these bounding box points I create a polygon and I insert this shape into the image. That means in image I insert this polygon around the face with the line width 4, and then step video player video frame. So with this video frame I'm giving this video frame to the video player object, and the video player object will show it as a video one by one. Okay, and in the rest part of this program, this run loop condition is checked with the video player. If the video player window is closed, that run loop will become false and you will come out of the while loop. Okay, now after that you just clear the camera object and release the hardware resources for video player. And let me show you what is inside that my face detect function. It is nothing, it is the same thing, same lines of code which I have shown in the first program. That means in this function, this name I have given from my side, it is not MATLAB default, and it will return the cropped image as well as bounding box points. Although for this program, as I said, I am using only this, not the cropped image. This I will use for next program. I have actually made a single function that use in both the programs. So inside this function, I have created this cascade object detector with the name face detector, and then I'm setting the threshold. I have already explained what is this threshold. And then when I pass this image to this face detector, I get bounding boxes as the outputs, right? So here, if bounding box is there, that means if face is detected, I am just doing some simple manipulation. I am doing just, I am increasing the size of this detected bounding box. Actually, the detected bounding box is very close fit on the face. So I am just increasing its size in all direction by the 50. So just to cover some head portion, that means some hairs, and some ear portion, and some the neck portion also, okay, of a person. So as per your requirement, you can increase or decrease these values 50 and hundreds. And after that, this with these boundaries, the image is cropped. I'm not using this in my current program, but I'm using this. Now these detected bounding boxes are now converted into the points. That means, so bounding box are converted into the all four corner points, right? And else means if face is not detected, then the cropped image is null, I assign, and the bounding box is a null matrix. So let me run this program, and I will show you that how it can detect my face in a video, and what happens if I hide my face. Okay, I will show you the both cases. So let me jump to the MATLAB. So let me open the editor. Okay, this program is already written here. So let me start this by pressing this run button. Okay, my camera is started. Yes, you can see my face. It's me, and you can see that yellow color bounding box in this video. And as I have assigned, if face is not detected, then bounding box is a null matrix. Okay, so let me hide my face with my hand. So you can see that the bounding box is disappeared. Okay, so face is not detected, and if I show my face, then it is again detected. In this video, you can see a lag. Actually, it is because of my weak hardware of my laptop. So if your hardware is powerful enough, then you won't face this lag. Okay, so let me close this video player. So when I close this video player, obviously that while run loop will break, okay, as I explained. So let me jump to my presentation. So let me go to the next program for face database creation. So this is the program where you can create the database of faces. Actually, there are so many databases are available on the internet for human faces, but if you want to make the database of your own faces, then you can use this program. Even this framework, this program will be utilized to create the database of many other objects also. So let me show you that what are these lines. First, we are initializing the webcam, and then we are asking that how many frames are required. For example, for one person you want let's say 100 images or 20 images per person. You can enter the required number of frames here, and then initializing a counter to enter in the while loop. So when count is less than equal to the number of required frames, this while loop will run, and the snapshot is capturing one image and it is going into the IMG, and this IMG is passed to the myFaceDetect function. The myFaceDetect function is the same which I have explained just before. Because this it is also returning the cropped image that I need in this case. So the same function will be used here. So since it is as you can see here, the cropped image as well as bounding box points. So here I am not interested in the bounding box points, I am interested only the cropped frame. So that cropped frame will be stored in some directory. So I am displaying this cropped frame. At the same time, if the crop frame, that means not is empty, that means inverted, it means the face is detected and we are getting some cropped frame, then you can store this frame into any of your folder. So first I have to give the path of the folder. So in the E directory, in these folders, I have created one folder, face database. So in this particular folder, I will store all those number of required frames. Okay, so you can copy this code as it is. Okay, with this I am right, the cropped frame will be written with the file name which I am providing with the loop. You can see, here this will provide the actually the file name. So since count is starting from 1 till NOF, that means number of frames. So all file names will be your 1 dot, 2 dot sort of things. Here you can see that I am storing the file in the PNG format. So the file will be stored as a 1.png or 2.png and 3.png and so on till number of required frames in that defined particular folder. So these are just display information, and after that your camera object is clear. So let me run this program in MATLAB and let's see how the face database is created. So before that, let me show you that folder. So in this current directory, this is the folder which I have created. So let me show you, this is empty right now. So after running the program, I must get the number of images, required images here. So let me open the editor, and this is my program which will create the face database. So let me run it. Okay, so it is asking me the enter the number of required frames. So let me enter the 20. So for each person I can create the 20 images, and let me execute it. Okay, so you can see my face is being displayed one by one, and here you can see in the workspace the numbers are being displayed. Let me hide my face. If I hide my face, then you can see there is no image displayed, and you can see the message also that no face detected in the workspace. And if I show my face, it starts recognizing again. Okay, so total 20 images are acquired, and let me see that folder. Okay, so you can see the folder that there are 20 images are captured, and this you can use as a face database. You can try this for several persons and you can create the face database. So this is my face which is captured at various angles. Okay, so this is how you can create your own database, and that's it for this video. I really thank you all for watching this. Goodbye.